Hello and welcome to this webinar hosted by GraphAware and Open Ownership. Today we'll be discussing unlocking complex ultimate beneficiary ownership investigations and the power of using both open ownership data and graph databases. Some housekeeping before we start. There's a Q&A section at the bottom of the Zoom. Please use that, send your questions through. We'll be answering those questions at the end of the session. Any questions that we can't get to today, we'll answer proactively after the session. A reminder, this session is recorded. Recordings will be sent out to your nominated email addresses at the conclusion of the webinar. And if there are any questions or queries that we haven't answered or anything that comes up after the webinar, please feel free to reach us at info@graphaware.com. There's three of us here today presenting. My name's Dan Newland. I'm the General Manager for GraphAware here in Australia and New Zealand. I look after our law enforcement and intelligence customers here in the region. Before I joined GraphAware, I worked at the Australian Tax Office, where I used beneficial ownership data to calculate tax avoidance, or identify tax avoidance. Before that, I worked at the Australian Federal Police using graph databases for a variety of intelligence use cases. Joining me today is Stephen Abbott-Pugh, Head of Technology at Open Ownership, and Christoph Williamson, CTO at GraphAware. Stephen, do you want to introduce yourself?
Thanks, Dan, and hi, everyone. I'm the Head of Technology for Open Ownership. We're a non-profit organisation helping countries all over the world with their beneficial ownership reforms, and I lead the team that develops the beneficial ownership data standard, which we'll hear more about in a minute.
Thanks, Stephen. And Chris?
Hi, everyone. My name is Christoph. I'm CTO at GraphAware. Been using Graph for more than 10 years and helping customers leverage graphs for a lot of use cases.
Excellent. Thanks, guys. So what is ultimate beneficiary analysis? An ultimate beneficiary is someone who enjoys the benefits of ownership without having the title directly in their name. So they're a business owner or a director without having that title directly in their name. It's somehow disconnected or through third parties. The UBO analysis is the process of finding that ultimate beneficiary. If there's a company or a trust, who is the ultimate beneficiary of that company or trust? And UBO analysis often requires analysis of complex structures with many, many levels of ownership. You might have a person that owns a company, which owns two other companies, which each own two other companies, and there's a variety of trusts and assets tied to that beneficial ownership chain or that beneficial ownership tree. So ultimate beneficiary analysis is trying to identify who is the ultimate owner of these assets, of these businesses, of this wealth attached to these company structures. Now, unfortunately, hiding assets through beneficiaries through this non-direct ownership has become a key strategy for fraudsters. The simplest form of this is non-direct ownership through family ownerships. So putting things in my wife's name or in my children's name or whatever it might be through family relationships and having non-direct ownership through those family relationships. But we do also now see complex networks of companies, trusts, super fund holdings that are deliberately set up to obscure ownership. These are becoming more and more common, both in the tax avoidance space and then also in the organized crime space. And traditional analysis techniques simply can't keep up with this rapidly increasing complexity. The structures are too complex to analyze and too complex to retrieve using traditional analysis techniques. Why do we care about UBO analysis, ultimate beneficiary ownership analysis? There's a variety of use cases across both the public and the private sector. Criminal asset confiscation. In some countries, law enforcement agencies have the ability to seize assets from those who have committed financial crimes. However, a lot of these assets, whether it be real estate, physical assets like planes or boats or cars, are not directly associated to those individuals. These individuals are using these complex company ownership structures and beneficial ownership structures to hide their association and their ownership of these assets. And so ultimate beneficiary analysis can uncover some of those linkages and ownerships to those assets, which can then assist law enforcement in seizing those assets. We also see it in the tax evasion space. Understanding company structures and the ultimate beneficiaries is crucial to understanding tax liabilities. And we also see it in the supply chain risk space, both in the private and the public sector. These complex company ownership structures are used to avoid sanctions and to hide who's really operating and financing certain companies. I mentioned earlier that traditional analysis techniques simply can't keep up with this growing complexity in ultimate beneficiary ownership analysis. You can see from the visual there, if we have this company ownership data stored in traditional tabular formats, we're literally manually drawing the lines and the traversals from company A to company B to company C and trying to do that manual analysis. And traditional data analysis techniques using tabular data stores simply can't keep up with the depth of those traversals that are required to identify complex ultimate beneficiary ownership trees. And this is where graph databases and solutions like GraphAware's product HUME are optimized for this type of analysis. Graph databases are optimized for traversing, for looking at the linkages between entities. And this traversal is required to uncover complex beneficial ownership structures. So graphs are optimized for doing these complex traversals, these depth traversals, to return both the company structures and the assets that are attached to these company structures. I'll hand over to Stephen to talk about open ownership.
Thanks, Dan. Let me just share my presentation. Open ownership has been working for the last 7 years to help countries all over the world with beneficial ownership transparency reforms. As you can see here, over 150 countries have now committed to doing more to make it easier to find out who really owns companies, trusts, and other types of entities in their jurisdictions. And the very important thing is the ability to connect that data between countries and all across the world. So what my team does is we have about 20 people based all over the world, and we support people with these reforms with the ultimate aim of giving them the information and the data that they need in order to investigate criminal networks, to tackle corruption, to look into procurement fraud, to enforce sanctions, for example. And so what we've done is we not only offer kind of guidance with people who are shaping their laws, and we do research in this, but we have also developed an open standard for beneficial ownership information, which can be used by anyone. And we're happy that there's a growing number of countries and other people who are using it. And so I'll just talk a little bit about what the standard can do and how it's built so that it can be of most use to help people investigating beneficial ownership structures. So the Beneficial Ownership Data Standard, or BODS, it's an open standard. It allows for capturing information on both legal entities like companies, but also legal arrangements such as trusts and trust-like arrangements. You can capture full ownership chains if you want to show all the intermediaries between a company and its ultimate beneficial owner, or you can actually also capture just the interest to say this person is an indirect owner, even if you don't have all of the details about those intermediaries. And we have a full range of interest that can be captured in terms of whether someone's a shareholder or has voting rights, or also if they just have some kind of control mechanism, like maybe they have significant ownership or control, or they're a board member, all the way down to the fact that they could benefit from and use the assets for a particular company or an entity. We also have a whole range of tools to help support people use BODS all over the world. All of those are open source and published on our website at openownership.org. And what you can see here on the right-hand side is an example of a diagram where there's a company which is owned by a trust, and then you can see how our data standard can be used to structure the information about the people who have a relationship with that trust. So the data model that we use for BODS is a statement-based model where we have 3 types of statements. We have entity statements, person statements, and relationship statements. And now in most cases, when you're looking at beneficial ownership data, actually it's fairly straightforward. You know, it tends to be people who own or control a particular company. You know, it's quite straightforward. In 90% of cases, it's simple. But by structuring the data like this, you can also capture the real complex ownership chains, which obviously are of most interest when it comes to investigating corruption and criminal networks, etc., as Dan talked about. So each of these statements is treated as a claim made in time. So it carries all the information you need to be able to connect, for example, multiple companies to a particular person, or multiple people or other entities to a particular entity. So all the information can be pulled together. And I'd be happy to share some more information about some documentation in the chat after this, so people can look more at this, the model. Now, as I said, we're getting a growing number of countries that are using this data standard, and also we've got companies that are starting to produce products that allow people to collect data in line with it. We're happy that at the moment, for example, the Canadian government has an issue where they want to collect beneficial ownership data for the whole of Canada, but there's a possible 14 registers that they might need to have in Canada, a federal one and lots of provincial ones, and they want to bring the data together. So we're very happy to be working with countries such as Canada who are using BODs to pull together the data that they have and to make sense of it from multiple registers. So why do people need more high quality beneficial ownership data? So Dan spoke to the fact that it's getting more and more complex to use this in tabular data formats, but also I just wanted to go through a few things about that we're seeing about how the landscape for this is changing and why countries need to do more in this space. So lots of standards all over the world have been updated recently, from the Financial Action Task Force through to the European Union, to demand adequate, accurate, and up-to-date beneficial ownership information, in some cases on both legal entities and legal arrangements. But unfortunately, most countries aren't doing very well in this space at the moment. FATF has found that only about 9% of countries are meeting its effectiveness requirements, so that means that they are collecting the information and using the information as they should. And they're continuing to kind of recommend changes that countries should push through. The OECD Global Forum has found that in about half of the jurisdictions they've looked at so far, there's not enough ownership information available. And other groups such as the Basel Index have found that beneficial ownership transparency remains a real challenge area. So everyone needs better data, but countries are having to develop their tools. Company registrars are having to change the way they work in order to collect this data. And so we hope that BODs offers a useful tool for them to do that. It's also worth saying that, as I've kind of hinted at, the transparency requirements have expanded. So it used to be that people were just asking for beneficial ownership transparency about companies, but as there's been more transparency there, more and more trusts are appearing in some of these beneficial ownership networks. It's also important, as Dan hinted at, to say, to be able to capture information about nominees or family members or people who are treated as kind of nominees or nominators in beneficial ownership relationships. I'm happy to say that BODs allows you to capture all of these types of arrangements and types of entities, but it goes without saying that there's more and more information that people need to capture on different types of entities. And so if you have a data standard that allows you to capture all of those, I hope that will be a very valuable thing, because it becomes easier to pull the information together if you have information on companies and information on trusts that really needs to be understood to build up the picture of what's happening with beneficial ownership networks. There's also a growing kind of understanding and research that's been done showing that countries can't act by themselves, and they really need to be able to exchange information and share information more internationally to be able to spot the kind of risks there are relating to cross-border payments or other places. So the study on the right here is from the IMF, talking about how a particular country in the Nordic region thought that the risks associated with money laundering and cross-border payments in its country were going down, but actually once they had connected that data, or the data they had on companies, with other countries in the region, they realized the risks were going up. It was just that the structures that were being used were becoming more international. So this needs to be, there needs to be more international cooperation. There needs to be more international data sharing. That becomes easier when you have higher quality data or more standardized data. And this is also something that's recommended by the Financial Action Task Force, that says that countries not only need to understand the risks posed by entities in their own country, but also those posed by people from other countries who may be linked to their country, for example, if they own a lot of real estate in the country. And finally, the benefits of having high quality data, hopefully in line with our standard, is that you have more opportunity to link it to some of the other types of data that are out there that people are most interested in when it comes to understanding the value of beneficial ownership data. So whether it be looking for companies or people that are winning an unusual amount of public procurement tenders, so to connect beneficial ownership with public procurement data, whether it's because you need to understand that if someone's sanctioned, that all of the companies that are connected to them are people that are politically exposed or are PEP. And also if you need to connect details about legal ownership data. So when there are companies, for example, that maybe appear on stock exchanges, so you don't have the full beneficial ownership information, but you have other sources where you can pull together information to do due diligence or know your customer checks. So all of these are easier to achieve and more supported if you have high quality beneficial ownership data. And like I said, hopefully in line with our standard, and we hope that it's a very useful tool that people can take advantage of. So now I want to hand over to Christoph, who's going to show you how you can make the most of BOD's data.
Thank you, Stefan. All right. Hi, everyone. I will demo how graphs help to unlock UBO investigation, and especially with the usage of HUME, our product. So HUME is a graph analytics platform. So graph is at the center of HUME, and most especially a graph schema. So this is the logical representation of our world. So the schema is here very simple for this demo. So we have person and organizations. Person can have ownership into organization, and organization can have ownerships into other organization. We also have sanction authorities that can sanctions, like issue sanctions on persons, organizations, and also values. Values is a generic type for representing assets like aircraft, ships, crypto wallets, all those type of entities, right? So that this is the schema. So when we want to visualize data, we actually reflect the schema on a graph database, especially in Neo4j here. The database is empty, just for the demo. We will go into how to ingest data in the bots format, but we will also see other type of data. Right, so let's ingest some data right now. So here are the open ownership statements. So if you want to quickly have a look at what a statement looks like, we can see it here. So those are 12 statements, so where you have addresses, identifier for a person, nationalities of person, the source of the statement, of the data for that statement, date of birth, etc. Like multiple names. So a person can have also aliases, etc. Right. So the important thing here is that this ingestion template is designed for the bots data format. So that means that every single country or registry that would use the bots data format would benefit for reusing ingestion pipeline and build it only once. Right? So we will import here some data, and we will refresh our visualization. So we now ingested a very small amount of data. Don't worry, we will go over some bigger data sets later, just to show how the data looks like. So we have person having ownership into organization, and ownership can have a percentage. So again, high quality data, very important. You can see here 25, but at the end of the day, we don't know, because this information comes from the UK Companies House, which doesn't provide real percentages, but will provide like windows, like between 25 and 50, between 75 and 100, etc., etc. So we like quality of information is generally very low in a lot of data sets, right? So the second data set that we will import is a subset of the open sanctions data. So open sanctions provide highly curated data on a couple of entities, mainly sanctions, know your business data, also open ownership data, etc. So it has a lot of different data sources, and we will ingest a subset of it. Right? So here, the principle for ingesting open sanctions data is similar to how to ingest bots data. However, it has a more variety of types, for example, vessels, airplanes, crypto wallets, sanctions, etc. So you have a couple of examples. At the end of the day, what you would do is map the data to a query that is able to represent the data into the graph database. So we will ingest that data as well. Finished. All right. Now, if I would fetch the remaining of the data, so here it's a HUME action. So this is the ability to create a query that is available as a simple click for the end user, for the analyst. So we have here the remaining data that was ingested. So we will just reorder a bit, and so I will just quickly change the styling to another predefined style for the nodes. So just to have colors. So the dark blue colors nodes are person coming from the open ownership data, and the green person nodes are the persons coming from the open sanctions data. And even with a very, very small subset of the data, we can identify already some problems. So let me take this person, Alisher Usmanov, and if I would find on the canvas similar people based on their name, I can see here we have Usmanov, Alisher. Okay, so this is problematic in general when using data coming from different data sources, right? It's not specific to UBO, but in UBO it happens a lot, right? So we have this person that is probably the same person. So if we look at the date of birth of this person, we have 9 of September 1953. And if you look here, we have September 1953. Forget the 01. In some data sets, they provide only the month and year of the date of birth. In some data set, the full date of birth, etc. So the problem is that if we would ask questions such as if Demetrios Sergides connected to that person, Irina Weiner, the answer would be no, because in the graph, there is no connection, there is no path between those two persons, even if we know that those two persons are the same, right? But it's not part of the data, which means that you cannot find insights from a graph without having those connections, right? So the next step that we will do, and this is generally a must-have in every UBO project, is we will perform entity resolution. For this purpose, we will use Sensing, which is a GraphAware partner. So they provide an out-of-the-box entity resolution software, which is available as API or etc. So it's very easy to embed into your application, and this is a very mature software as well, right? So I will go here. Before starting anything, I will just say that our integration supports Sensing out of the box with recent different features as well. So every time you write data or update data into the graph, we can capture those events from the graph database itself. So generally, you only get the ID of the nodes or the relationship. So what we do is that every time a person is created or updated, we will find the subnetwork of that person. So all the relationship like family, ownerships, addresses, etc. The goal is then to transform this into a format that Sensing understands. So basically, we transform to a big JSON object. So you can here ingest, you can use Python snippets to actually transform the data. And once the data is transformed, it will look like this for Sensing. You have all the features of a person or another entity type, can be organization, address, etc. We then send this information to Sensing via API, an HTTP call, and Sensing will return to us if entities have been affected. So as soon as it detects that two entities are the same, like they have a match together, they give us an ID, and we send them to Kafka for asynchronicity. And then we materialize the resolved entity. So we materialize the fact that two persons are the same into the graph. So I will start those workflows here. It will be very quick. Okay. All right, it's done. So what I will do now, we go back to our visualization, and I will select all persons. Right now, I will just say refresh the nodes from the database. Like, is there new information in the database that can be brought to me on the screen? And the important aspect here is that this person has a new badge, right? It's like a hammer. The hammers in our style, so this is totally configurable, says that this person has been sanctioned by any authority, right? So, however, this information is not available in the OpenShift data. It is only available in the Open Sanctions data. And how we do this is actually under the hood. I said we materialize the fact that two entities are the same. So we create this fact here as what we call an entity group. So this is the representation of the unification of two or multiple, more than two persons having been identified to be the same person, right? So the fact that we know it is a sanctioned person in another data set, this information only lives on the canvas. So in general, you would have to do a lot of updates in the data to be able to perform this type, to be able to materialize this information. We took an approach here to just compute this information as soon as we bring data onto the screen. So just to show you how that works. So we have an action here. Let's say for every node that we bring on the screen of type person, we will find if they have a connection to an entity group, and that entity group is connected to another person, and if that has been sanctioned. If yes, we return a Boolean flag for a computed property on the node, right? So this is how we can style our nodes and provide immediate insight, even if you're traversing data only from one data set or from one country, etc. Right? So sometimes it can be a bit too much explosion into the graph, so you can onto the screen, so you can choose to view groups or resolve the entity on their own, like here. So you see that automatically it gives a bit more global insights into the analysis. So you can see that those persons are the same, those persons are the same, etc. Right? Another type of grouping, which is very interesting in UBO investigation, is if we would look, let me get all the person reloaded and bring all the entity group here. So if we would look here, so we have this group here. Those persons are family members, right? So this means this one, they're family members. So sometimes you are looking at ownership at family level, right? So this is not easy to do, but with a bit of grouping, we can say, okay, those are all the same family because they have family relationship between them. We can give them a group name. We enable grouping, and here we have vision on what this group actually owns together, right? So now that's enough to play on very small data. Let's go to a visualization where we'll actually use the whole OpenShift data set as well, which is the whole company's house registry plus the Danish tax registry, etc. So we have here more than 10 million person in organization and 11 million relationships approximately, right? So we can start by finding paths that are more complex. For example, ownership structures where there is at least 5 5 levels of relationships, right? So we can easily, without having to write a query, just use our visual expander, 1, 2, 3, 4, 5, and check if there is some matches in the database that satisfies this data. So we can bring everything here to the screen. And when Dan was saying before that traditional data structure are not fit for purpose for investigating ownerships, this is kind of true. So let's take this network of ownership and see how it would look like as a table, right? So here, we can see here, this is a table. We have 114 entries, and as a table, or Excel sheet, it's not very, very straightforward to understand actually what is the structure of this network and ownership, right? So in the real world, this structure looks more like this. Right? So you can imagine the benefit from switching from tables to graphs to understand the ownership structure of companies and persons, etc. Right? So, right. So another type of analysis we can do is, so we'll remove everything here. Okay, is to check the identify ownership structures that contains entities where their jurisdiction is on the European tax haven blacklist. So the EU has a list of countries that are considered tax havens, right? So they don't fit those criteria. And this is kind of important, especially in terms of due diligence to identify those networks. So again, we can use here. We will remove for now. We can simply use jurisdiction, and we can select a couple of jurisdictions. We don't have to select everything. So we'll take Bahamas. Sorry, this is not Bahamas. Bahamas, Anguilla, the Virgin Islands, and Panama. Right. So here we can generate a preview and find those networks here. So we can also only take a subset and expand those subsets. Again, as soon as one of those entities is in a blacklisted jurisdiction, we can add visual marker for the analyst to immediately spot, and like not having to open properties of nodes, etc. So they can easily spot where there is something of interest or something risky on those entities, right? So, all right. Another type of analysis, which is forbidden, especially in the UK and probably in other countries, is identifying circular ownerships in structures, right? So circular ownership are kind of not easy to find in other types of data structure. And I want to show you how easy it is to do in a graph. So here, I will just show you the query. So this is a 5-line query. So we will find organizations that have at least one outgoing and one incoming ownership relationship to them. And then we find, we just expand from those to find the circular ownership paths, right? So again, very easy to do as an analyst. Every morning, you can just click on this button here to identify circular ownership. Right? Let me move to course here. Right. So those things are fraudulent in the world. Right? All right. So just to show you. We can also, for example, find person, like traversing from the whole data, find path where we cross data sets. So that means that I need to have an entity group here, then it needs to be incoming, and then I want to find, for example, their ownership into organization, right? So we can come here, and all those paths actually represent cross data source, thanks to entity resolution. All right. And the last bit of the presentation is how to automate this work when you're not on the laptop or on your desktop or the computer, right? So Jerry, analysts are interested for sanctions, for example. So how can I be notified as soon as there is a new person or organization that is connected to a sanctions, any sanction, right? So for this, we have what we call HUME alerting. So you can predefine patterns that you want to match into the graph. Those patterns will be run every X amount of time. So here, every 30 seconds, for example, it will collect the first results, keep them, and then continuously track if there are new results compared to the initial one every 30 seconds, right? As soon as there is a new one, it will send you an event, an email, etc. Right. So what we'll do as an analyst, I will subscribe to this monitoring. For example, alert me when new person is sanctioned, right? And I can select this program pattern. Then I don't want to receive email now. I will start it. And you can see that it completed in a couple of seconds because this is not too big data. And it will run every 30 seconds. In the meanwhile, I will go here and create fake data. So like the name of a person called new sanctioned person. And that person will actually be connected to be sanctioned by some authority, like that one. All right. So I will run that query. So that means that new data will be in the graph. If we look here, it ran at 14. So maybe we're just a bit too late. So in max 30 seconds, oh, we were not too late. So I receive a new event that tell me that this new pattern was detected in the graph. It was not existing before. So we can explore this pattern, check, expand. You have access to the full graph again, right? So, and that's it. Thank you very much.
Thanks, Christoph. Thanks, Stephen. Alrighty, we'll do some Q&A. Reminder that you can use the Q&A functionality within Zoom to send through your questions. Chris, we've got one for you from Zarak. Does GraphAware also do data cleansing or post-processing to remove duplicates from data sources? For instance, small variations in spelling of names, spaces, punctuation, etc. This can result in 2 entities instead of 1.
A very good question. Thank you. So I want to mention a couple of things, right? So data quality is very important at every stage of a project, of course. So we don't provide out-of-the-box data cleansing and post-processing, etc., because it's very different for any type, any source of data that you have, right? So, but we do it. There are a couple of examples. I will actually show. I'm still sharing? No, I will. Let me share again. I can show you an example when we started ingesting ICIJ datasets, for example. So the ICIJ data has 2 CSV files that are called officers and intermediaries. Those do not contain the type of entity. So you just have a name. You don't know if it's a person or an organization. And this is very common when you have datasets that provide the term legal entity as a type, right? It can mean a person or an organization, which is very problematic for downstream systems, like entity resolution, right? So you can end up in a case where a person will be considered the same as an organization because they have a name, address the same, for example. So to give you an example here, we, for example, used LLM on the ICAJ data to classify the data for us. Right. So here you can see I have this is the data coming from ICIJ, just a name, and then this is the prompt we're sending to the OpenAI to ask him to classify if it's a person or an organization, right? So then when we run this, we send it to OpenAI here, and then we receive the response from OpenAI to, oh, sorry. That says, okay, this is an organization. This is the classification from OpenAI. We asked it to separate with 2 semicolons, etc. Right. So and we did this for the approximately 800,000 entities from ICIJ, which took some time, right? So we don't have out of the box cleansing, but this is very important. I want to say that name variations, date of birth, formats, all those things will be very well handled by Sensing, right? So let me show you something. Let me start this thing. If I'm going to my visualization here, and I'm asking, okay, why are those persons actually considered the same, right? So they will, again, we're using LLM, not for the question. We're asking LLM because the response from Sensing is a big JSON. So we ask the LLM to summarize this big JSON into a human sentences, actually, right? So because otherwise it would be a lot of work to represent as a table, for example. So here, this is this. So, for example, date of birth match at 90% with the other one. The name matches 92%. Nationality match 100, etc., etc. Right. So, and you have the same features here for the second record. So the second person in the open sanctions data, etc. So yeah, this is very well handled. But yes, then you have use cases with different languages for the same name, etc. So it's not easy as it can look, right? So, yeah.
Thanks, Chris. A few more questions from the chat. One from Nicholas, or 2 from Nicholas, sorry. Is this native GraphAware functionality that you're showing, or is this a custom application that you've built on top of Hume?
I'm not sure I understand. Like the whole software? Which functionality?
I suppose the demo and the schema that you're putting together, Chris, and the actions that you're running.
Everything here is Hume except calling external services like Sensing or OpenAI, etc. Otherwise, all the platform here is one unified platform, and this is generally a good a benefit so you don't have to learn a lot of different tools. Right?
Mm-hmm. Another one from Nicholas. Can you natively visualize semantically inferred relationships without materializing the relationships?
Yes, if we can logically define what the inference is, for example, if let's say that if this person is connected to this person is connected to this person as well, then this is also connected to this person. We have the ability, I cannot show it now in 1 minute, to return virtual relationships as well. So the same as computed attributes, for example, computed properties, we can compute virtual relationships that can also be brought to the screen. So yes, we can do that. And it's generally, it's something we do very often. One example unrelated to BO that I did recently is representing the movement of a person. So the only thing you have is a person with an array of location, and we can do virtual nodes to represent the movement with relationships like next position, etc. Right. So yes, we do that very often.
Thanks, Chris. A few questions, anonymous questions. Can I ingest my own CSVs with a watch list containing names and organizations?
Yes, definitely. I worked on another project where we were using the Dow Jones watch list, for example. So yes, definitely.
Excellent. Another one from Anonymous. Can I connect to a webhook or Kafka stream to ingest new data continuously, or do I need to trigger data updates manually?
No. So Orchestra is definitely one of the weaknesses of Orchestra is that it's not task-based. So Orchestra is stream-based. This is why you have to stop manually. So yeah, we can connect to Orchestra, to Azure, Events Hub, all those things. So it's very we done for mission critical and real time applications. So yes, definitely.
Another one from Anonymous. Does every user have the right to modify the ingestion workflows? Do you have role settings within HUME?
Yes. It's per role. So you need to have not only access to the workflow itself, but for example, here you have a data, what we call data resource. So you can connect to as many Neo4j databases as you want, many services as you want. So you also need to be explicitly granted access to the resource. So if you want to create a workflow, the admin should give you access also to the Neo4j database with the right credentials, or to a Kafka topic, etc. So yes, it's very secure. So also we work a lot with government, so we have a lot of security around this.
Fantastic. I think we've covered all of the questions from the chat, Chris. Just give it another 10 seconds to see if we get any more coming through.
Let me check. I see open. No. So there is from Eva, the application. From the chat. I see only one question, which we would require a lot more explanation. The last one around the duplication.
Yeah, might have to take that one offline and do it out of session.
Yeah.
Excellent. If there's no other questions coming from the chat.
Thank you very much.
Thank you very much for joining today, and thank you to Stephen and Chris for some fantastic demos and presentations. Again, any further information, please reach out to either of us or any of us, either on LinkedIn, or you can reach GraphAware at info@graphaware.com. But for today, that's all. Thank you very much for your time. We'll speak to you all soon.